Hello, my dear doctors. Welcome to the lecture notes discussion on statistics. My dear, listen very carefully. I'd like to talk on some of the introductory talks before starting these statistics. In your exams, my dear, there will be only 5 questions from this chapter, like the statistics. So, my dear, statistics is one of the biggest chapter to know, to do the research, and this is basically the medical research related how to do that. So my dear, is one of the biggest chapter. So if you want to know them very well, so it's quite time consuming, my dear. So as because in your exams only the 5 questions are coming, so we need to be a bit of technical so that we can make our answers and getting the most important topics in our exams so that we can make our answers correctly with confidence, my dear. In these lectures, what is my aim for you peoples? To go for the 5-star topics, my dear, mostly, and invest your time mostly onto the 5-star topics because these are usually encountered. What is aim here? The aim is to correct at least the 3 questions out of the 5, and for preparing yourself for the next 2 questions, it needs a long study, my dear. So once again, my tips and tricks is that just follow me, and once again, just take some of the important data and some of the rules and formula to do some of the mathematical problems, and these are really encountered in your exam. So yes, getting them by your heart and putting them this important data and making your answers in that way, the 3 questions will get it, my dear, easily after having these lectures, my dear. So what is my suggestions? That invest your time here a bit shorter rather than giving much time to study more and more and reading them vastly. Yes, it's really difficult because these terms we are not acquainted with that until otherwise you are attached with some of the study design and also some research projects. So it's really difficult for a clinical students to go through them details and getting them really difficult. So my tips and tricks, just to get some of the important words and getting by your heart, because these are tasks in your exams, my dear, and some formula so that you can solve some of the mathematical problems and giving them answers with confidence, my dear. So let me start by having some of the topics overview here. So these are the topics will be covered here. And yes, the first topic here, the normal distribution. I'll go in different ways, my dear, because we'll go here in this chapter focusing on to the questions first and coming back to the some of the discussions and then going back once again the questions so that we can remember, and making some of the important SS boxes and reading them will be really helpful. So here is the normal distributions, my dear. And if you go down, you see some of the photo here. There's another photo. Just look at there. Normal distribution photo. And once again, another normal distribution curve that I said. Another curve. Yes, another curve. Similar curve that I have given here so that you just go through them a bit of visual impressions. So my dear, one of the SS box, let's learn it fast. Whatever the statistical term that you're using, just make a notes first on this one. This SS box says that the normal distribution means that 1 to 3 and 70, 95, 99. So get this by your heart, my dear. Once again, say with me, 1 to 3, 70, 95, 99. If it is 1 equal to 70, 2 equal to 95, 3 equal to 99, what does it mean? We will understand immediately after this. But please write it down and get this by heart, my dear. So just say with me 1, 2, 3, 70, 95, 99. Say with me once again. 1, 2, 3, 70, 95, 99. 1, 2, 3, 70, 95, 99. 1, 2, 3, 70, 95, 99. Yes, my dear doctor. I hope that everybody got it. So what is that? 1, 2, 3, 70, 95, 99. So let's get back now to the down to the questions. As I said, the approaches will be towards the question first. It is written here, the serum potassium is measured in 1000 patients taking an ACE inhibitors. So we know the ACE inhibitors potassium is getting high. So the study has shown that the serum potassium is measured in 1000 patients taking the ACE inhibitors. The mean potassium is 4.6 millimole per liter with a standard deviation of 0.3 millimole per liter. So make it circle, standard deviation, the word. And here the potassium, circle, 4.6 and 0.3 millimole per liter. So once again, the serum potassium is measured in 1000 patients taking an ACE inhibitors. The mean potassium is 4.6 millimole per liter with a standard deviation of 0.3 millimole per liter. Which one of the following statement is correct? You see the A, B, C, D, E, there are different percentage. 95, 95, 99, 68, 68. Values lies in between the 4.5, 4.7.5. Values lies in 4.3, 4.9, 5.2, 4.5, 4.75, 4.3, 4.9. The answer is given here. 68.3% values lie in between 4.3 and 4.9. My dear, what does it really mean? 4.3, 4.9, how it comes? And once again, the 68.3%. What it is? And what is the source of these statistical values? So let's get back here. You have the 4.6. So if you just minus 0.3 from the 4.6 to the 4.3, and once again if you plus 4.6 plus 0.3 equal to 4.9. So this is the standard deviation. What we learned, my dear, we learned the normal distribution, one of the SS box, that is a 1, 2, 3, 70, 95, 99. Say with me, my dear, once again. Just close your eyes and just remember this one. And this is very important, by the first data and the first box that we are learning, and that will have the tremendous effects for the next steps, my dear. So once again, say with me, 1, 2, 3, 70, 95, 99. My dear, listen very carefully. If the one standard deviation, the 70% of the values of each data lie in one standard deviation, means the 1 means 70%. 70% means a bit data, that's 68.3%. I just made it 70%. So yes, 70 means the 68.3%. Just remember the 70. So what I said, the 1 means 70%, 2 means 95%, and 3 means, once again, 99%. 1 means the 1 standard deviation 70%, 2 means 2 standard deviation 95%, and 3 means 3 standard deviation 99%. My dear, just go with me and be having this passion, so that will be helpful. Just go with me. So once again, 1 standard deviation equal to 70% means the 70% of the values lies in between 1 standard deviation of the mean potassium level, so mean level. So 1 standard deviation from the mean. So mean here, the 4.6, 1 standard deviation means plus minus 1 standard deviation, means the minus 0.3 means the 4.3, and plus once again 0.3 means the 4.9. So 1 standard deviation means the 4.3 to 4.9 millimole per liter, and that happens the 68.3% values lies in between this. The options may be the separate things, means the 2 standard deviation. What will be the 2 standard deviation? 2 means 0.6. Standard deviation into 2, 0.3 into 2, 0.6. So if you cut 0.6 here, means the minus 0.6 is the 4 and plus 0.6 is the 5.2. So 4, 5.2. You have to look for the 4 and 5.2. You see here is the 4 and 5.2. What we have done? We have done the 2 standard deviation, but the 2 standard deviation we learned it 1, 2, 3, 70, 95, 99. But here is a 99, so this is wrong. This is 95. 95 means 95.4%. I just made it 95. So this is wrong answer. And once again, the 3 standard deviation, 3 means 3 into 0.3 means 0.9. So if you minus 0.9, so what will be happen? Minus 0.9 means that's 3.7. You don't have any data 3.7 here. Means once again 0.9 means once again the 5.5. So once again 5.5 and 3.7 data is not there. So if it is something like the 3 standard deviation should be the 99.7%. Means the 99%. So once again the summary talk my dear. Just to getting this box means the 1, 2, 3, 70, 95, 99. It does mean 1 standard deviation 70. 70 means 68.3%. 2 standard deviation 95 means 95.4%. And 3 standard deviation means the 99.7%. Just forget them, the 7, 4 or whatever, the 68.3. Just remember 1, 2, 3, 70, 95, 99 my dear. Once again 1, 2, 3, 70, 95, 99. So let's get back to the normal distribution curves, the first topic as we are learning here. So here's the normal distribution is also known as the Gaussian distribution or bell-shaped distribution. It describes the spread of many biological and clinical measures. Properties of the normal distribution: symmetrical. Normal distribution means you studied trials. So there we have the numbers of the data that you have. You collected the mean, you have the mode, and you have the median. So if the mean equal to mode equal to median, so this is called the normal distribution. So the normal distribution, the word that you need to know is the symmetrical, mean, mode, median. As I said, the 1, 2, 3, you see the 1 standard deviation, 2 standard deviation, and 3 standard deviation. As I said, the 1 standard deviation is 70, means the 68.3. 2 standard deviation means the 95.4%, and 3 standard deviation 99 means the 99.7%. So what I said, the 1, 2, 3, 70, 95, 99. It does mean, my dear, standard deviation from the mean. So if you have a mean of one data, so 1 standard deviation, the 68% of the values will be lies in the 1 standard deviation. If you take more deviation from your mean, so the 95.4% values lies in the 2 standard deviation. More deviation means the 3 standard deviation is the 99.7% values in your data. This is often reversed so that the within 1.96 standard deviation of the mean lie 95% of the sample values. Same talk. So yes, 1.96 standard deviation means the 2 standard deviation, my dear. They made it 1.96 and they made the 95%. So we need to remember 1, 2, 3 so that we can remember 70, 95, 99. I will say this one many times, my dear. Yes, so that you can do the perseverance and can get it by your heart so that you can apply your knowledge. Yes, my dear. Yes, the range of mean, 1 standard deviation to the mean, you see, range of mean minus 1 standard deviation to the mean plus 1 standard deviation mean is called 95% confidence interval. This is 1.96 standard deviation. 1.96 means the 2 standard deviation. 2 means 95%. Confidence interval. If a repeat sample, the 100 observations are taken from the same group, 95 of them would be expected lie in that range. So this is a very good example. So if you take the repeat sample of the 100 observations, so the same group, 95 of them would be expected lie in that range. Means the 95% within will be this range of the mean. Like as we already have seen that the potassium level, 2 standard deviation. So that 2 standard deviation will be within the 90, means the 95% of the people will have this 2 standard deviation. It states that the average of the samples of the observation of the random variables independently drawn from the independent distributions coverage in distribution to the normal, that is become normally distributed when the number of observations sufficiently large. So normal distribution, we will get the normal, circle the word the normal, and the sufficiently large. If you take the large observations, the normally distributed. So yes, the normal distribution curve is a bell shaped when the mean equal to median equal to mode. Everybody understand what does this mean, my dear? Mean, what does this mean? Mean means yes, you have the 10 data of the potassium level from the 10 peoples in a certain fixed conditions. So you just add all the 10 variations and divide it by the 10. So yes, this is called the mean. So mean is just a mean. And median, the middle point of the mean, different observations of the 10 peoples, it will be the median. And mode, of course, if 10 peoples will have the potassium level like the 4 millimole per liter, in a 5 peoples, then there of the other fellows, so definitely the 4 will be the mode. So when the mean will be the 4, median will be the 4 millimole, and mode will be the 4 millimole in potassium level. So normal distribution curve will be the bell shaped. I hope that you got it. Means the mean, median, and mode, everything is equal to the same. So it is called the normal distributions. So normal distribution, if you make the bar diagram, you see that. So you'll see the data that will be give a bell-shaped curve. So that is called the normal distribution curve is bell-shaped. That's it. So you see another bell-shaped curve. So if you put the data and make the data, so this is the bell-shaped curve normal distribution. So you see the normal distribution curve, mathematical concept called the normal distribution. Many natural phenomena demonstrate the pattern called the normal distribution bell curve. The world tends to be bell-shaped. So you see the most outcome occurs in the middle. Yes. It is if you are in the tails lower, if you are in the tails in the upper, and even very rare outcomes are possible here and also possible here. So normal distribution. This curve is important, my dear. So this is the 0, means the mean value. So you see the +1 and this is the -1. This is nothing but, my dear, 1 standard deviation. So 1 standard deviation means you see the 34.13% on the right hand side and 34.13% the left hand side, and both together the 68.26% of the data from the mean, the 1 standard deviation. My dear, this is very important. If the standard deviation of the data that you got like 0.5 and the mean is the 4 millimole per liter in the potassium level, so 1 standard deviation, what does it mean? So here's the 4.5 right hand side, and left hand side it will be the 3.5. So 3.5 to 4.5, these data will be found in 68.26% of the peoples. So this is called the 1 standard deviation. That's why you call it the 1 standard deviation equal to 70%, 2 standard deviation 95%, you see the minus 2 and plus 2, 95%. And once again, the 3 standard deviation is a 99%. So it can cover the full data in your hands. The same talk, you see, the mean is the middle value, the top, the middle value here. So you see the 68.3% data in the 1 standard deviation, 2 standard deviation 95.5% data, and 3 standard deviation you see the 99.7% data. My dear, yes, just to remember once again, 1, 2, 3, yes, 70, 95, 99, 1, 2, 3, 70, 95, 99, 1, 2, 3, 70, 95, 99. So here is also same talk. You see the 1 standard deviation is a 70, 95, 99. Normal distribution, normal curve standard, same talk here. The 1 standard deviation is once again the 70, 95 and 99. And this is just a fractions of the different standard deviation like the 0.5, 1, 1.5, 4. So it's just in fraction. But we need to know 1, 2, 3. Once again 70, 95, 99. Same talk here is you see the 1 standard deviation 70, 2 standard deviation 95, 3 standard deviation is a 99. So 1, 2, 3, 70, 95, 99. So once again you see 1 standard deviation, 2 standard deviation, 3 standard deviation. So 1, 2, 3, 70, 95, 99. So yes, the summary box once again 1, 2, 3, 70, 95, 99. I hope that my dear, this normal distribution curves and understanding the standard deviation and the percentage of data that in between the 1 to 3 standard deviations and the percentage like the 70, 95, 99. So yes, if you read them now, so you can get it. Yes, the 1 standard deviation 0.3 means the 4.3 and 4.9 data is 70%. So these are the right answers. So now let's talk the standard deviation. So standard deviation is the measure of how much dispersion. So box is the deviation. First learn and get it by heart, then understand, having conceptions, and once again need to know what does it really mean. The deviation means the dispersions, my dear. The word says that the deviated from the mean. That is called the standard deviation. So standard deviation is a measure of how much dispersions exist from the mean. So standard deviation equal to square root variance. This is the calculation of the standard deviation. So once again, standard deviation means equal to square root variance. So once again, same talk, the 1, 2, 3, 70, 95, 99. Standard deviation. So once again, the talk here, the standard deviation, the dispersion from the mean, and standard deviation equals square root variance. Standard deviation tells us how much measurements for a group are spread out from the average, means the mean. So I have the small standard deviation, you see the small, and large standard deviation. Yes, if the deviation is more and more. So here is in calculation of the standard deviation. You see the standard deviation equal to variance, square root variance, and variance is nothing but the sum of each value in the data set minus mean of all values in the data set square divided the n for number of the value in the data set. So this is nothing but the variance, my dear. So variance is calculated by the summation of each value in the data set minus mean of all values in the data set square divided by, and just sum of all the data set here divided by n. This is called the standard deviation, is calculated by this way. So here is the standard deviation, same talk, x minus x dash n minus 1 as well. So once again, 1, 2, 3 standard deviations. So once again the 70, 95, 99, same talk here. Next topic is the skewed distribution. Skewed distribution, what does it mean by that? Skewed distributions, as we already learned, the normal distribution equal to mean equal to median and mode. Skewed means deviated from the normal distribution. So yes, the skewed distribution means two skewed distribution that we are getting, positively and negatively skewed distribution. So if you see the positive means the greater than arrows there, the box that we need to learn. So positively skewed distribution, the mean greater than median greater than mode. If the mean is greater than, means the mean is the highest, then that of the median, then that of the mode. And negatively, once again, mean is the lowest, then that of the median, then that of the mode. So to remember the above note, there are alphabetical order, think positive going forward with once negative going backwards. So here's you see the symmetrical distribution as with the normal distribution. The mean, median, mode is a single point. But whenever the mean is getting highest, then that of the median, then that of the mode, that is called the positive skew. And you see the shape of the distribution is changed here. So this is the positively skewed. In contrast, the negatively skewed, the mean is the least, then the median, then the mode. So mode is the highest one. So this is called the negative skew. So same here, we call the positive skew means you see the right skewed, the positive skewed distribution or positive skewness. The right skewed, you see the mean, median and mode, and here is the once again the mean, median and mode. So left skewed, the negatively skewness. So once again the positively skewed and negatively skewed rather than normal distribution. So this is the positively skewed. Positive skewed, the mean is the highest grade, and here is the mode is the highest grade. Symmetrical distribution, normal in contrast, asymmetry. So here is the question, which one of the following best describes the negatively skewed distribution? So negatively means mean, negative means less than median, less than mode. So this is the box might be one of the question usually come. So this is a double star topic. Next topic, my dear, is a standard error of the mean. So we can go to the question first. Which one of the following statements regarding the standard error of the mean is correct? So standard error of the mean in a short form, that the SAM, that standard error mean SAM is correct. They say the answer is that gets smaller as the sample size increases. Standard error of the mean. The word itself says that the standard error. Just can you remember? Can you just feel this word? The error of the mean. That is the word. The standard error of the mean. Error gets smaller as the sample size increases. Means the error will be less if the sample size increases. Yes, my dear. Just simple talk. Error of the mean, error will be less if the sample size increases. Error will be less if the sample size increases. Of course. So now we can get back what is written there, the standard error of the mean. SAM is a measure of spread expected for the mean of the observations. Means it will say the how accurate the calculated sample mean from the true population mean. Sample mean from the true population mean. So this is called the standard error of the mean, SAM. So we get the standard error of the mean, standard deviation, square root n. N is nothing but the number of the sample size. It is the number of the sample. So that's why the number of the SAM gets smaller if the number of the sample is increases. If you know this formula, means the standard error of the mean equal to standard deviation divided by square root n. N is the number of the sample size. 95% confidence interval lower limit equal to mean minus 1 standard deviation, 1 standard error of the mean, and upper limit equal to mean plus 1.96 standard error of the mean. Might listen very carefully here. The same talk, 95% confidence interval, as you already learned, can you just remember the normal distribution and having the standard deviation 1, 2, 3, 70, 95 and 99, it has been the 2 standard deviation with the 95. So here is also the same. Of course, lower limit of the mean will be the 2 standard deviation, 95% confidence interval. The same thing applied here is as well. Just 1.96, just consider this is nothing but the 2 standard deviation or something like that. The above form is a slight simplification. If a sample size is used less than 100, then it is important to use the student's T critical value to look up the table to replace the 1.96 with a different value. If a different confidence interval is required, 90%, then 1.96 is replaced with a different value. For 90%, that would 1.645. So this is very important, my dear. So results such as mean value are often presented along with the confidence interval. Results such as mean value are often presented along with the confidence interval. For example, in a study, mean height in a sample taken from a population is 183 centimeter. You know that the standard error or with the standard deviation of the mean is 2 centimeter. So 2 centimeter means the 2 standard deviation means 2 into 2, 4 centimeter. So 4 centimeter plus and 4 centimeter minus. Minus 4 centimeter means 183 minus 4 equal to 179, and 183 plus 4 centimeter equal to 187 centimeter, plus minus 2 standard error of the mean. It has been the 95% confidence interval in these heights. So same talk here, that in a normal distribution we talked about the 1, 2, 3, 70, 95, 99 right there. So here is the 2 standard deviation or 2 standard error of the mean. Yes. So the standard deviation is nothing but the standard error of the mean, just standard deviation divided by square root the number of the sample size. This is the big differences from the standard deviation, that is the standard error of the mean. So somebody talk, the standard error of the mean is the standard deviation, my dear. Just remember this one. It just divided by the square root the number of the sample size. So here is some confidence interval standard error of the mean. A confidence interval is a common and sometimes misunderstood principles in medical statistics. A formal definition may be a range of values for a variable interest constructed so that this range has a specified probability of including the true value of the variable. The specified probability is called the confidence interval. The specified probability, circle, confidence interval. And the endpoints of the confidence interval are called the confidence limits. So endpoints of the confidence interval. In a simpler term, a range of values within which the true effect of intervention is likely to lie. Like as we have seen, the 95% of the confidence interval means that 95% of the data will be lie in between the 2 standard deviation of the mean or two standard error of the mean. The likelihood of the true effect lying within the confidence is determined by the confidence level. For example, confidence level 95% confidence level means that confidence interval should contain the true effect of intervention of the 95% of the time. So yes, for example, confidence interval at the 95% confidence level means that the confidence interval should contain the true effect of intervention 95% of the time. So confidence interval and standard error of the mean that you already learned. So once again, the summary talk of the standard deviation equal to standard error of the mean. But here's the standard error of the mean equal to standard deviation divided by the number of sample size square root. What does it mean? The number is increases, the standard error of the mean will be reduced. So just to remember, the standard deviation, standard error of the mean is nothing but the standard error of the mean, means the standard deviation. So that's why once again the 1, 2, 3, 70, 95, 99 that you need to remember. So here we see the standard error of the mean, once again the standard deviation divided by square root n. This equation implies that the sample error decreases as the sample size increases. Of course, means the standard error of the mean is nothing but the standard deviation but divided by the number of the sample size. So number of the sample size increases, so error will be reduces. So the same talk that you need to know, the 5-star talk, my dear. Because it suggests that we want to make a sampling error as small as possible. We need to use a large number of the sample as we can manage. So yes, if you need to reduce the error in our sampling, so we need to take large number of the samples. Means if you need to take a data or study for potassium levels after taking the AC inhibitors, so if you take the, rather than 100, you take the 500,000 peoples together. So yes, you'll get the standard error of the error will be less. Standard error of the mean. So here is the statistics, same talk, the n, you see the 15, sample size 135 and 500. So this photo is very important. A larger sample size decreases, the narrows the standard, means the standard error. So you see, whenever you have the large sample size, the values of x square will have the less variation, of course, and therefore will be closer to 3,200. So larger sample size up to a point generates a better approximation of underlying population because it minimizes the sampling error. So you see the huge number of the, if you see the n equal to 500, so the color code here, the blue color here, so number of the samples of 500, you see the standard deviation or standard error of the mean is the less than that of the red color than that of the green color. So 135 and 15 respectively. So the sample size increases, standard error of the mean or standard deviation is also reduced. Standard error allows you to infer how well the sample mean matches up to the true population mean. Helps you to determine the confidence in the data collected, and so 95% is a plus minus 2 standard error. Just remember this one. Means the 1, 2, 3 as we already learned. So yes, my dear doctors, so getting the standard error of the mean, the summary talk, the standard error of the mean equal to standard deviation divided, means the standard deviation divided by the sample size square root. And means the sample size increases, the standard error mean, error of the mean will be really reduced. So that's why the sample size increase, the large number of the samples is needed to have a less or least possible error in your study, my dear. So the next topic, my dear, is the significant test types. Means you do trials and study by doing some of the tests, and which tests are really significant or not. So we need to do some of the tests, my dear. And this is called the significance test, and these are the type, and which category of the test that we need to do for which categories of the data. So we need to know them very well, and these are very hot topic for the exam as well. So significance test types, the type of the significance test used depends on whether the data is parametric, something which can be measured, usually normally distributed, and non-parametric. So the two important words, that parametric, which can be measured, is a normally distributed, and which cannot be measured is a non-parametric data. So data are the two categories, the parametric and non-parametric. So the parametric data that you need to test, thus, and non-parametric test include, you see, the parametric test include the student's T test, paired or unpaired, and Pearson's product moment coefficient is a correlation. Non-parametric test, the Mann-Whitney U-test, unpaired data. Wilcoxon signed rank test compares the two test observation on a single sample. T-squared test compare the proportions or percentage, and circle the bold headings and bold words, my dear. The Spearman-Kendall rank correlation. So it is written the paired data refers to the data obtained from a single group of patients. Paired data and unpaired, measurement before and after an intervention. And unpaired data comes from two different group of people. They're comparing response to the different interventions, the two groups. So paired data means the single group, the two different data. And unpaired means the two different groups, the two different data, something like that. So parametric test, once again in the box, non-parametric test, the same talk. The parametric paired t-test, unpaired t-test, Pearson correlation, and the Wilcoxon rank sum test, Mann-Whitney test, and Spearman correlation. So here is also another box parametric and non-parametric test. And some of the parametric tests applied for the different type of the data, and here is which non-parametric test to use, and parametric, once again non-parametric test data. I would like to go first, some of the question first, so that, yes. An endocrinologist performs a study to assess a patient's HbA1c level is correlated to their LDL level. So this is the correlation, assuming both the HbA1c and LDL normally distributed. So what will be the following statistical test is most appropriate to perform? So once again, the HbA1c level to the LDL level, a correlation. So what test should be done? The answer is the Pearson's product moment coefficient. So for the correlation, what we do the parametric and non-parametric test. And parametric normally distribute Pearson's coefficient, and non-parametric the Spearman coefficient. So we put a box, my dear, this is helpful. So for the correlation, that we do the Pearson's, P for parametric data, and non-parametric is an S Spearman's. So this is the parametric is the Pearson's, and non-parametric is the S Spearman. Just remember, my dear. So once again, parametric equal to Pearson's, non-parametric S Spearman. What I said? Parametric Pearson's, non-parametric S Pearson's. Just remember this, my dear. Pearson's product moment coefficient test is most appropriate as the data is parametric and the study is seeing the correlation of two variables. McNemer's test is non-parametric used to nominal data. So Nemers, circle the Nemers and circle the nominal data to determine whether the row and column marginal frequencies are equal. So Nemers nominal data. The study measures a patient's serum cholesterol before and after. Serum cholesterol before and after a new lipid lowering therapy has been given. What type of significant test should be used to analyze the data? So this is the student's paired t-test. Is the answer. So serum cholesterol before and after. So before and after. So paired, yes, the t-test should be done because these are parametric data, and in a single group, the before and after that you are looking for the serum cholesterol level. So that's why this is the student's t-test. Like already we learned here, you see, can you go get back here? Parametric test, the student's t-test, the paired and unpaired. And paired data, that the single group of the measurement, the before and after intervention. So paired means before and after. So we can make a box here. The student's paired t-test, of course the t-test, the parametric data that we are doing. So once again, what you are doing, the before and after. Paired equal to before and after. So just write it down. The student's t-test, the paired test, is the before and after. So simple. The serum cholesterol before and after new lipid lowering therapy. Like if you do the statin before and after cholesterol level study in a single group of patients. So yes, that is, you need to do the student's paired t-test. So the paired means the before and after. Just remember, my dear. Next, a study designed to see whether the degree of chest pain is linked to troponin I value for patients admitted following in marker infarctions. So degree of chest pain linked to the troponin I value for patients admitted following a marked infarctions. The pain is assessed during the using a scale of 1 to 10, with 10 representing the worst pain that the patient has ever experienced. So once again, this is nothing but the correlation. So once again, the degree of chest pain, so this is non-parametric data. So non-parametric, can you remember, we learned it, the correlation, parametric, Pearson's, and non-parametric, Spearman. So significant is used to investigate these links. So this is non-parametric correlation, non-parametric Spearman. So yes, this is the Spearman is the answer. This scenario looks at the way that the values are correlated. So correlation. As the data is a non-parametric, particularly the observation-based pain scale, Spearman rank correlation coefficient should be used. A study compares the sensitivity of the two tests of the colorectal cancer. The first test is a sensitivity 85%, the second is sensitivity 91%. What type of the significant test should be used comparing these two results? So comparing percentage and proportions being compared to the chi-squared test, my dear, should be used. So somebody box with the chi-squared test. Squared. T squared equal to percentage or proportions. Yes, my dear doctor. Chi-square is a percentage or proportions. Which one of the following significant tests is most appropriate to apply? A study design is assessed to the efficacy of the new antihypertensive medications. Two groups of the pupils are randomly assigned. One to take the established drug for 3 months, whilst the other takes the new drug for 3 months. So established drug and new drug. So efficacy of the new antihypertensives. The blood pressure measured before and after. Can you remember? I said the before and after means the t-test and the paired t-test. There is then a period of medications, off period, medication 1 month. After this period has elapsed, the medication that the group received swapped around, and again the blood pressure measured before and 3 months later. The difference in blood pressure after the respective medication is calculated for each patient. So measurement of the blood pressure is once again the parametric data. And once again the parametric data before and after is a t-test. In a single group is a paired t-test. So here's the students paired t-test. This describes a crossover study. As we are comparing the parametric data from the same patients, they swapped medication halfway through the study. The students paired t-test should be used. As I said, the students paired t-test is nothing but the parametric data, of course. And this is before and after in a single groups. Which one of the following would invalidate the use of students t-test when performing a significant test? Would invalidate using it with the data that is not normally distributed. So students t-test needs the normal distribution, means the parametric. So the parametric data needs the students t-test, means the normal distribution. What is the most appropriate statistical test to apply to this data? A study is designed to look at the efficacy of a mandible advancement device in reducing snoring. Efficacy of mandible advancement device. Reducing snoring. The severity of snoring was assessed by the partner using a 10-point scale before and after. Using the device, 50 people are involved in this study. My dear, listen very carefully. You cannot count, but this is based on the 10-point scale just to ask the partner. So this is, the partner is saying that the snoring is 0. So no snoring, 1 is more, 2, more and more respectively, 10 is the highest snoring. So this is a non-parametric data. So if it would be the parametric data, so we should go for students t-test. But here is the non-parametric data. So this is very important. So non-parametric data that we need to do efficacy of the mandible advancement device in reducing the snoring. So this is called the Wilcoxon signed rank test. Is the right answer here. The data in this study is a non-parametric paired. Non-parametric paired comes from the same population. These factors make the Wilcoxon signed rank test the most appropriate statistical hypothesis test to use. So can you get back once again the parametric and non-parametric data or the test? So parametric, as we already learned, the students t-test paired and unpaired, and non-parametric here we already learned the square means the proportions or percentage, And now we have seen the Wilcoxon signed rank test compares the two sets of observation on a single sample. So compares the two sets of observation. So here is also the compares. So I am just making a compare the word the Coxon. Make it box in a non-parametric data. So can you get back once again the question here? Yes. So we make a box here, the Coxon equal to compare. Coxon equal to compare. So compare meant a study is designed to look at the efficacy of a mandible advancement device in reducing snoring. The severe snoring assessed by the partner using the device. The 50 people are involved in this study. So this is the non-parametric pair and comes from the same populations, and this the Coxon is a compare. Which one of the following significant test is used to analyze data which is measured and follows a normal distribution? Analyzed data is measured. So measured means the parametric data, and normal distribution, of course, the student's t-test. Measured means the parametric data. So yes, my dear doctor, I'd like to summarize here the test, the significance test that are really important. So starting here, the boxes that I'd like to tell the summary box once again. So if you make a box, significance test. So mind you listen very carefully. The parametric and non-parametric. So always look for the parametric. So parametric, simple, equal to student's t-test. T-test. Parametric means the student's t-test means equal to before and after. It can be paired, it can be unpaired, but yes, the student's t-test. But this is parametric. In contrast, if I say the non-parametric, in that case, the Coxon equal to before and after means a compare. Before and after. Now we talk about the correlation. Correlation, under the headings of correlation, once again the parametric equal to Pearson's. Non-parametric equal to S. Yes, non-parametric equal to S. Pearman. Correlation done. Next talk. Yes, my dear. Once again, the non-parametric heading. You got a data, non-parametric. You got a proportions and percentages. Compare. So you need to do the squat. And just squared. test equal to proportions or percentage.